Alright, I'm going to use a series of these metallic magnetic beads to connect into arches, both a pointed arch and a round arch. Okay, so I have here a pointed arch using 25 of the units and a rounded arch using another 25, so it's the same amount of units. And so now we're going to test the width of the bases using this pink post-it notepad. So it's the same size on every, or same length on every side. I'll test how far apart it is from each base. So this one, the rounded arch, it fits entirely in between. Fits in between with a little bit of room on the side. Okay, let's see if it's smaller on this one. And it is. The base is smaller. Any farther apart and it becomes a rounded arch. So if I try to make this one thinner, like to have the same width of base of a pointed arch, if I push it together, it wants to become pointed and it's not sturdy. It's not steady because it can't support that much weight. It needs to be farther apart in order to stay upright, because that confirms the theory of why rounded arches are less stable, because that outward force is being exerted, while this one, the rounded arch, wants to be pulled in. So test number 1, base width, or the width apart from each base, supports the finding made in the book. Alright, so now test number 2, I'm going to exert pressure on top of these arches. So first we have the pointed arch. Just going to push down, try to keep it right in the middle. It bends a little bit, but it's taking quite a bit of pressure to do it. This is, at first, nothing really happens. So I really give it a push, and it kind of bends down to the side a little bit. So, not super strong, and this is just magnets, but it takes a little bit. Round arch, I'm just going to give it a tap. See, even with the tap just itself, it's already moving a lot. If I push down a lot, it totally bows outward. That outward force exerted right here where it comes and meets the upright. So that test seems to support the book says about how rounded arches are weaker. I also made 2 reinforced arches. Here's a pointed arch with 2 layers, and here's a rounded arch with 2 layers. It's kind of like a flying buttress. It's not the same structure or anything like that, but it does offer more support. So we'll see if that changes anything. So again, I'll push. Taps doesn't really do anything. If I push hard, it kind of pushes down. Yeah, there we go. So it doesn't take very much, but it doesn't do anything when I tap it hardly. A little bit of that bouncing. And if I tap this double reinforced one, it's still, see, a lot more movement. Push hard. Yeah. So clearly the rounded arch is weaker. So here we have a diagram between rounded arch and a pointed arch. Obviously an imperfect drawing, but imagine them to scale, being they both come from here and both go to the same height. How many units it would take to do that? And then these numbers just kind of indicate about how much pressure it would be. So like this one at the very bottom has like 5 units of pressure on it. You could argue that it's only 5.5, whatever. But this one has the most pressure, this one has the most pressure, same here. Up to where these ones have like no pressure because there's nothing on top of them. So let's see how many units for the rounded. So about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 units. And then the pointed, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So less units in the pointed arch or the rounded arch to get to the same height.